Hello there and welcome to a brand new lesson. This is Hard Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at partial fractions. Specifically, we are looking at what? The case 1, which is distinct linear factors. On our left-hand side are the answers to the previous trial exercises. You can compare them to what you had and then do your corrections as well. So by the end of this lesson, you should be able to understand what partial fractions are and why we use them. You should be able to identify when a rational expression has a distinct linear factor in the denominator. To be able to decompose proper fractions with distinct linear factors using the cover-up method. And then finally, you should be able to verify our results by combining the partial fractions. So without much ado, let's quickly look into it. Now, as the lesson proceeds, you would hear me using these vocabulary. So I want to take time to explain some of them before we begin. First of all, when we say partial fractions, it simply means you are breaking a single fraction into the sum of smaller fractions. So you remember initially we did addition and subtraction of fractions, where you have one fraction, that is a partial fraction, adding to another one. This time around, in terms of partial fractions, the resultant we want to rewrite it back into the sum or difference of the fractions that give us this. So for instance, if you take what we have here, this is a compound fraction, and we are looking for these two fractions that would sum up or subtract to give us this. That is what we mean by partial fractions. So we come to a proper fraction. From our normal knowledge on fractions, a proper fraction is simply that whose numerator is less than the denominator. So when it comes to rational functions, it is a rational expression where the degree, this time around, our focus is on the degree. So if the degree of the numerator is less than the degree of the denominator, then it's a proper fraction. So here we have 3x. The degree of x is what? 1. And this is x squared. The degree of x is 2. This becomes a proper fraction. Why? Because the degree of the numerator is less than that of the denominator. On the other hand, if the degree of the denominator is less than that of the numerator, then we have an improper fraction. Not only less than, but if it is less than or equal to, or in other words, if the degree of the numerator is greater than or equal to that of the denominator, then we have an improper fraction. For cover-up method, we would get to know it when we start solving questions. So before we dive into the case 1, we want to look at the general overview or the 4 cases we have. First of all, the case 1, that is the distinct linear factors. When you have a fraction, so a compound fraction, in this case, when I say just a fraction, you should understand we are talking about rational functions. So if we have p over an x minus a, then x minus b, if you have something like this, we call the denominator we have here linear factors. Linear because x minus a here is a linear function, and x minus b here as well is also a linear function. If you want to rewrite this as or in terms of the original fractions that were added to give us this, then we say it is equal to a constant, that is a, over the first linear, that is x minus a, then plus your b, which is your second constant, over the second linear factor, which is x minus b. This is what we call the distinct linear factors. So if you have more linear factors, then each and every linear factor is going to have its own constant at the top. So if it continues, and let's say we had x minus b, they are going to say plus c over x either plus or minus b, whatever the case may be. You see, so these are what we call linear factors. Now, on the other hand, we might have linear factors, all right, but then they are repeated. That is, repeated linear factors. So in the case where we have repeated linear factors, then this time around, there's going to be a square over here. Or in other words, you can simply say p over x minus a and then x minus a. So it is repeating itself. Now, anytime we have it of this form, we don't just write it as we did for the linear factors, those that were not repeating, but rather you take your first one, which is your first constant, a, over what you have in here, what is repeating, which is x minus a, and then you have a plus b over the whole thing you have here as your denominator. That is x minus a all squared. And then you solve. So this type is what we call the case 2, the repeated linear factor. That is the linear factor with what? A square on top of it. It is repeated. And this is how we evaluate it. You see, the most important thing is if you know how the base equation is supposed to be, the rest is just simple algebra, and you'd always be able to find your way around this. Let's look at our third case. That is case 3. So if you have p over, we have x minus a, then into bracket, and x squared plus bx, and then plus c. You realize that there are two factors we have here. This first one is just a linear factor, as we considered right here. You see, and we said with the linear factor, all we do is we give it a constant, so a over x minus a. Now for this second factor here, it may be that you cannot reduce it. For such, we call them irreducible quadratic. There is no way you can reduce it. That is, there is no way if you multiply or find the factors of c and then add and subtract them, you are getting the b. Hence, we can't factorize. For such, you are going to say after you give what you need to do, after you have given a constant to the linear factor, you then say plus, you have a bx plus c all over the irreducible factor. So that is your x squared plus bx and then plus c. So what we are saying is for the numerator, instead of just a constant, that is either a b or a c or a d or whatever, no, but rather we need two constants. The first constant with an x and then plus the second constant alone. So our first constant becomes a coefficient, and then the second one is just without a variable. That is the type 3. And these are the three main types. As I'll be explaining this case 3, you understand that case 3 will now fall within any of the types you have over here. So once again, for case 3, if the denominator appears such that you are not able to factorize, then you give it a numerator. The numerator will be a bx plus c. As simple as that. But for the improper, when we began, I said for improper rational functions, it simply means the degree of the numerator is greater than or equal to that of the denominator. So anytime you have something of that form, then you would first of all need to divide. So if you have 4 over 3, there's an improper fraction. What do you always do? You'd first of all change this to an improper fraction. You first of all change this to a mixed fraction, which gives you a 1 whole number, then a 1 over 3. You see, or we have 1 plus 1 over 3. So you are to divide and rewrite the fraction as the sums of two fractions, after which you now focus on the other and then you work on it. So the other you get, that is the proper fraction you get, might either be of type 1, type 2, type 3, and then you'd follow the right procedure to solve it. With that said, we want to focus on case 1. That is, for this lesson, we are focusing on distinct linear factors. In our next lesson, we'll focus on the repeated linear factors. The next one, we move to case 3, and then we would sum it all up with case 4. Without much ado, let's look at case 1. Now, when it comes to case 1, as we have said, the denominator is made up of what? Linear factors. If you have the denominator being made up of linear factors, or anytime you are given the partial fractions, make sure you factorize the denominator fully so that you would be able to tell that there are no repeated factors or irreducible quadratic. So if you're able to factorize fully, then you now write your decomposition form with your known constants. Now the number of constants depends on how many linear factors you have. So for this, we had just 2 linear factors. Hence, we need just 2 constants. You see, if you're able to do that, you now multiply both sides by the full denominator to clear the fractions. You substitute the root of each factor, or you expand and equate the coefficient. Now, there are 2 methods we use to find the constants, that is A and then B. And in this lesson, we'll go through both so that at your own disposal, you choose the one that you think you would understand best. But I would always advise you master both, after which you write the final answer and verify by combining. With these steps, let's now quickly solve some examples. It says you have to express 5x plus 1 all over x plus 1 into bracket x minus 2 as partial fractions. So we have 5x plus 1 all over an x plus 1 and then an x minus 2. This is the fraction we have, the compound fraction we have. So we want to write it into its original set of fractions, which were either added or subtracted to give us what we have here. Now you observe that they are linear, the denominator are linear factors. So if they are linear factors, how many are they? There are 2 distinct linear factors. So we are going to say it is going to be what? A, the first constant, over the first denominator, which is what? X plus 1. And then plus a B over the second denominator, which is x minus 2. Here's what we have. So if you're able to get this, how you proceed depends on the method you want to use. It's either the cover-up method or the method of undetermined coefficient. So I'll go through both so that at the end you decide the one that you would prefer. Now, using the cover-up method, there are 2 ways we can do it. There's one that is very, very short, and I'll take you through that. So if it is A we want, then all you want to do is you pick this function you have here. That is the 5x plus 1 all over. Now, the denominator we use this time around among this linear function depends on what we are solving for. So, if it is A you are solving for, then you don't include A's denominator. That is the x plus 1. No, you don't include it, but you include the other one, which is x minus 2. You see? And also, if it is B we wanted, we'll still take this numerator, which is 5x plus 1. And we are not going to use B's denominator, but rather we'll use what? X plus 1. Then the second stage is you evaluate these that you have at the values of x for which the denominator of the constant you are looking for equals 0. What this means is, at this particular point, there is a we want. So let's substitute x for what? The value of x that makes a's denominator 0. And that is what? -1. You see? Because if we substitute -1 to what we have here, the denominator is going to be 0. So we solve at x equals -1. Then we come to b as well. So for b, what value does the denominator of b become 0? That is x equals what? 2. How am I getting it? For that of a, it is simply x plus 1. Equating it to 0 and then making x the subject, you have x equals -1. And for that of b as well, you have x minus 2, which is equal to 0. Making your x the subject, you have x which is equal to 2. So this is what I did to get my -1 and then to solve. Hence, solving for a, we have our a which is equal to 5 into bracket. You are substituting x to be what? -1. So 5 into bracket, -1 plus 1 all over -1 minus 2. Once again, -1 from the fact that we are saying x equals -1. Simplifying further, you have 5 times -1, which gives us a -5. -5 plus 1 gives us a -4. So we have a -4 over -3. -4 over -3 simply gives us our a, which is equal to a 4 over 3. Then solving for b, this time around we substitute x for 2. So 5 into bracket, 2 plus 1 all over, we have our 2 plus 1. Simplifying further, we have our b, which is then equal to 5 times 2 gives us a 10. 10 plus 1, we have an 11 over 2 plus 1, which is a 3. Hence, our a is 4 over 3, and then b is 11 over 3. Let's go over the cover-up method again. All I'm saying is, if it is a we want, then we'll take the numerator of the compound fraction. That is what we have over here. So 5x plus 1. Then all over, not the denominator of a, no, but rather the other denominator. So if you are not taking the denominator of a, then we are taking x minus 2. So that is the x minus 2 we have here. But then the evaluation is going to be with the value of x that makes a's denominator 0. So x plus 1 equals 0, hence x equals -1. That is what we have done here. And then we substitute and solve for a. For b as well, it is going to be b equals the same numerator, but not with the denominator of b, but rather the other. So x plus 1, as we have done over here. But then we'll be evaluating it as x equals 2. Where do we get the 2 from? 2 is the value of x that makes the denominator of b 0. Then substitute and then solve for your b. So if we are to rewrite our fraction in terms of partial fractions, then it simply means that our 5x plus 1 all over x plus 1 into bracket x minus 2 is equal to 4 over 3 over, that is the a. A was 4 over 3, so over x plus 1, and then plus an 11 over 3 over x minus 2. Now, anytime you have a fraction of this form, we usually write it as, so the numerator of this fraction is going to be so 4 over, then this denominator comes down, 3 into bracket x plus 1. You see, you have our plus 11 over 3 into bracket x minus 2. And that is your partial fraction of x plus 5x plus 1 over x plus 1 and then x minus 2. This is what we have over here. Now, anytime you finish, you can check and see if what you did is actually correct. There are two ways of doing it. The first one is you would add all of this. That is using our lesson on addition of rational functions. You can add them and then determine whether you get to the same thing we have over here. The other method is substituting. So you substitute any value for x. If you get the same answer on both sides, then it simply means you are correct. Hence, I'm going to substitute with what? 0. So 5 times 0 gives me a 0, then plus 1, we have a 1. So 1 over, if I put a 0 here, 0 plus 1 gives me a 1. And if I put a 0 here, I'll get a negative 2. 1 times negative 2 gives me a negative what? 2. And if I'm to evaluate it, it's simply negative 0.5. Now let me substitute x as 0 here as well and see if I'll get the same answer. So I have a 4 over 3 times, this is going to be a 0 plus 1, which is 1. So 3 plus 1 gives me, 3 times 1 gives me a 3. Then plus, we have 11 over, we have a 0 minus 2 gives us a negative 2. Negative 2 times 3, we have a negative 6. If you want to add these, our LCM is what? Negative 6. Or let me say, 11 over 6, negative 6. So to rewrite it, we can just remove this negative from here and bring it up here so that it becomes a minus. So evaluating, we have our LCM being 6. And then 3 into 6 twice, 2, 4, 8. So we have 8 minus 11. 8 minus 11 simply gives us a negative 3. So negative 3 over 6. 3 into itself once and then into 6. How many times? Twice. So negative 1 over 2, which is the same as what we have over here. So it confirms that what we solved for is correct. That is the cover-up method. Now let's look at how the method of undetermined coefficient works. It is important you understand both, because if we continue with case 2 and then case 3, you won't be able to rely just on the cover-up method, but then you have to apply both so that you'll be able to solve the coefficient. So understanding it here is the best thing to do. So for the method of undetermined coefficient, there is also called the equating coefficient method. You would see why it is called so very soon. So we have our 5x plus 1 over x plus 1 and then x minus 2. And we are saying it is equal to a over x plus 1 then plus a b over x minus 2. So the method of undetermined coefficient simply says we should first of all clear the denominators as if you are simplifying fractions. You see, how do we clear the denominators? You multiply each and every fraction by the LCD. See, so by the LCD, we simply mean for the 5x plus 1 all over x plus 1 into bracket x minus 2, you would multiply it by x plus 1 into bracket x minus 2. You see, for this first step, I'm going to do it so that you see. But as we continue, you would see the pattern and there will be no need multiplying, because even before you multiply, you would know the answer you have to expect. So we are going to also multiply this we have over here by the same LCD. This is it. It is going to be a multiplication. And then we would also multiply this last one over here also by this same LCD. Not forgetting our plus. So by the end of the day, you realize that x plus 1 cancels out x plus 1. X minus 2 takes out x minus 2. And then for this section, we have x plus 1. So x plus 1 takes out x plus 1. Then x minus 2 also takes out x minus 2. If you want to write what you have left, for the left-hand side, we have 5x plus 1. And then for the right-hand side, we have a into bracket x minus 2. So x minus 2, then plus b into bracket x plus 1. So x plus 1. Looking at what we have as a resultant, we can simply say anytime you reach this stage, just write the numerator, because you should always expect the denominator to cancel out, because this would always be your LCD. So the denominator is going to cancel out, hence we have only the numerator, and then the a multiplying the denominator but without its denominator, you see. So a is going to multiply the other denominator. So if there are so many denominators, if there are 3 linear factors, then all you do is let a multiply all of them but excluding its own denominator. In the same way, b is also going to multiply all but excluding its own denominator. And that is what we have here. So a multiplies x minus 2 and b multiplies b plus x plus 1. So after this stage, what we do is we expand. So we have 5x plus 1 is equal to a into bracket x minus 2, then plus b into bracket x plus 1. Now, this one seems longer, but then I assure you that it is the best. As I said, if you really understand it, it would help you when we go to case 2 and then case 3. That is why I'm taking my time for you to get it. Hence, we have our 5x plus 1. We want to expand. So a multiplies x, and then a multiplies 2x to give us an ax, then negative 2a. B also does same. So b times x gives us a bx. Then b times 1 gives us a b. After this stage, we group like terms. So grouping like terms, we have 5x plus 1, which is equal to all those with x's. Ax, then plus bx, and then we come to the negative 2a. So negative 2a, and then plus the positive b. You see, so with this, you would like to rewrite it as a plus b or x, and then you can rewrite this as simply plus b minus 2a. It is fine. So if you're able to get this, what you do is you create a system of equation. Creating a system of equation, what we mean is we equate corresponding terms. So that is to say, if we take x, so for all those that are x, all those that have x's, this here, we take its coefficient. We have 5, which is equal to, on our right hand side, this is what have the x. So 5 is equal to a plus b. This becomes your equation 1. Then for your constants, so you say for constants, what we have here as our constant, it's 1. So 1 is equal to, and what we have left here, a b minus 2a. You see, or better still, let's write it as negative 2a plus b. So that is our equation 2. After which you now solve the system of equations. You see, if you want to solve the system of equation using simultaneous equation, then we can say equation 1 minus equation 2. If you want equation 1 minus equation 2, that is using the elimination. You know, there are so many ways you can do this. Either the elimination, the graphical method, substitution, using the matrix. It's all up to you. But in this case, I want to use the elimination. So with the elimination, I'm saying equation 1 minus equation 2. That is going to be, you have equation 1, which is 5 is equal to A plus B. And I'm saying minus equation 2. Equation 2 was 1 is equal to negative 2A and then plus B. So with that, we have our B minus B. That takes off the B, you see. Then we have A minus negative 2A. It becomes A plus 2A. So that gives us what? A 3A. And then finally, we have a 5 here minus 1. That gives us a 4. Making A the subject, we would have an A which is equal to what? 4 over 3. And if you have your A as 4 over 3, you just substitute your A into any of the equations. So we can say let's go to the next page. So put A into equation 1. So A into equation 1, it simply means for A plus B, or for 5, which is equal to A plus B, we are going to have 5 equals A, which we said was what? 4 over 3. So 4 over 3 plus B. Then all you have to do is to make B the subject. To making B the subject, we multiply each and every term by 3. So that we have a 15 is equal to 4 plus 3B. Making B the subject, we have 15 minus 4, which gives us 11 is equal to 3B. You divide both sides by 3. We have our B is equal to 11 over 3. And that is all. So we have our A, which is equal to 4 over 3, and our B, which is also equal to 11 over 3. Hence, we can once again write our conclusion, right? So it comes down back to this line over here, where we have our A and then our B. Then we go on to write it as what we have here. So this is the cover up rule or cover up method, and then the method of undetermined coefficients. They are both very, very handy and very useful. We would solve another example where we would use both methods, and our advice, as I said earlier on, that try as much as possible to understand both methods, as it will be necessary as we move to the other cases. Cover up method alone cannot solve all coefficients. Hence, you need to also master the method of undetermined coefficients. So looking at our second question we have here, it says we have to decompose 3x minus 1 all over an x squared minus x minus 2. So we have 3x minus 1 over x squared minus an x and then minus a 2. The first thing we need to take note is that the denominator is not written in its factorized form. Hence, you need to factorize the denominator. The denominator was given as x squared minus x minus 2. If you want to factorize, it's the quadratic. So since the coefficient of x squared is 1, we then look for the factor pairs of 2, which when we add, will give us what? A negative 1. That is definitely a negative 2 times what? 1. If we add this 2, we are getting a negative 1. And if we multiply, we are getting a negative 2. Hence, if we are to factorize, we have an x plus x. That is x squared plus x. If you have to factorize, we have x plus 1 and then x minus 2. This becomes our factorized form. Hence, our question is going to be rewritten as 3x minus 1 all over the x plus 1 and then the x minus 2. Now, since we want to write it in partial fractions, or we want to decompose, the denominator has linear factors. So we are going to say it's equal to a over x plus 1, then plus b all over the x minus 2. We have learned of two methods we can solve for our constants. The first one being the cover-up method. So let's start with that. So with the cover-up method, we need to first of all solve for our a. So to solve for our a, we say a is equal to the numerator we have here, which is 3x minus 1 all over the denominator, but excluding a's denominator. You see, so that is x minus 2. And we are evaluating it at x equals negative 1. That is the value of x that makes the denominator of a equals 0. Then for our b is going to be equal to the same thing, that is the 3x minus 1 all over excluding the denominator of b, and that is x plus 1. We are evaluating at the value of x that makes what? The denominator of b equals 0. So that is x equals 2. You see, so we now do our evaluation. So our a is equal to 3 into bracket x. This time around our x is negative 1. So 3 times negative 1, which gives us a negative 3. Negative 3 minus 1 gives us a negative 4. So we have negative 4 over x, which is negative 1. So negative 1 minus 2, that gives us a negative 3. And when simplified, we have 4 over 3. Then we come to our b. So substituting x as 2, we have 6 minus 1, which is a 5. Then 2 plus 1, which is also a 3. You see, this implies that a partial fraction of 3x minus 1 all over x plus 1 and then x minus 2 is then going to be equal to our a, which is 4 over 3 all over the x plus 1, and then plus b, which is 5 over 3 over what? X minus 2. But it is appropriately written as 4 over 3 into bracket x plus 1, then plus 5 over 3 into bracket the x minus 2. And that gives us what we have right here. Now, if you want to check whether or not you are correct, you can add this fraction using the addition of rational functions. Or better still, you can substitute values of x to make sure you are getting the same on both sides. Hence, let me test for x equals what? 0. So at x equals 0, we have 3 times 0, which gives us a 0 minus 1. That gives us a negative 1 over, this gives us a 1. Then 1 times negative 2, that gives us a negative 2, which is equal to a 0.5. It's just like, this is similar to the previous one we did. But the only difference is we were supposed to do our own factorization. So for this, we have 4 over 3 into bracket 0 plus 1 gives us a 3, then plus 5 over 3 times negative 2, that gives us a negative 6. This negative affects this to give us what? A positive. This negative then affects our sign, and hence we are going to get a negative over here. Now if you have to subtract and this becomes a positive. So this negative sign is going to affect this one, and that makes it what? Negative. Hence, if you have to subtract 5 over 6 from 4 over 3, we are going to get a 0.5 as well. And that confirms that what we did was correct. Now, this is the cover up method. But if you want to use the method of undetermined coefficient, let's see how we go about it. So with the method of undetermined coefficient, how do we go about it? All we need is the numerator. You see, you remember we have 3x minus 1. We are saying it's equal to a into bracket. It is going to be x minus 2, then plus b into bracket, x plus 1. Remember, for the first one we did, I said we pick only the numerator here. Why? Because this whole fraction is going to be multiplied by the LCM, the LCD, that is the LCM of the denominators, lowest common denominator. And this whole thing here is the LCD. So it will just cancel out itself. Then when we come to x plus 1, x plus 1 also cancel out the x plus 1. We'll be left with what? X minus 2. And that multiplies the a. That is what we have here. X minus 2 also takes out x minus 2. And we'll be left with x plus 1. And that is what we have over here. After this, what we do is we open the bracket. So that we have a times x, that gives us an ax, then a times negative 2, which also gives us a negative 2a. Then we have b times x, we have bx, and then b times 1, giving us what? A b. So grouping like terms, we have our 3x minus 1, which is equal to ax plus bx, ax plus bx, and then plus the constant terms, which is the negative 2a, and then plus b. So with that, we have our 3x minus 1 is equal to a plus bx. Then for our constant, we have plus negative 2a, and then plus b. So equating like terms, looking at that which has the x, they will be equated with each other, and then the constant terms will also be equated to each other, so that it will imply that 3 is equal to a plus b. This here is our equation 1. Then for the constant terms, we have negative 1 is equal to negative 2a, and then plus b. And as I said, you can use any of the methods of simultaneous equation to solve. From equation 1, we know our b is equal to 3 minus a. How do I get a 3 minus a? We are keeping b here, and then we take a to the other side, so that it becomes a negative. So 3 minus a. So let's put this b into equation 2. So you say put b into equation what? 2. And that is to say, for equation 2, instead of negative 1 equals negative 2a plus b, then we are going to get negative 1 equals negative 2a. Instead of the b, we have what? Plus 3 minus a. Grouping like terms, let's bring all the numbers to the left hand side. So I have a negative 1 minus 3, which is equal to a negative 2a minus a. That gives us a negative 4, which is equal to negative 3a. Making our a the subject, we have a, which is then equal to a 4 over 3. Now let's put a into any of the equations to solve b. So put a into, let's say, equation 1. You know equation 1 says 3 equals a plus b. So if you are putting our A, we have 3 equals 4 over 3 plus B. And if you want to make B the subject, then it simply implies that our B is equal to a 3 minus 4 over 3. 3 minus 4 over 3 then will give us a 5 over 3. You see, so using the same method, we've gotten our A, and then we've gotten our B. And we do our needed substitution as we have done over here, and then we get our partial fractions. Now, don't let the length of this method scare you, okay? Because as I said, you would need it in the subsequent cases as well. So with that said, let's look at our last question for this session. So looking at our last question we have here, you realize that it says we have to decompose 2x squared plus 3x plus 1 all over x into bracket x minus 1, then x plus 2. You realize that the denominator has 3 distinct linear factors. So it implies that our 2x squared plus 3x plus 1 all over x into bracket x minus 1, then x plus 2 is going to be equal to a over x. That is, a takes the first linear factor plus b over x minus 1. It takes the second linear factor. Then you have plus c also over x plus 2, which also takes the third linear factor. You see, so with that, once again, we can use the cover-up method or the method of undetermined coefficients. So using our cover-up method, we would simply say our A is equal to, so we are going to evaluate the function 2x squared plus 3x plus 1 all over. We are writing everything but excluding A's denominator, you see. And for A's denominator, which we are going to exclude, we'll be left with what? X minus 1, then x plus 2. And we have to evaluate it at x equals the value of A's denominator, that gives it 0. This time around, it is just x we have over there. So we'll be evaluating at x equals 0. Let's quickly do that. We have our A equals, for the first term, x equals 0 gives us a 0. X equals 0, so it gives us a 0 here. Hence, we have a 1 over. This gives us a 0 minus 1, which is a negative 1. Then a 0 plus 2, which is also a 2. Negative 1 times 2 gives us a negative 2. Hence, we can say our A is equal to a negative 1 over what? 2. Then we now come and evaluate, cover up for what? B. So our B is also the numerator, which is 2x squared plus 3x plus 1 all over. We are writing everything excluding B's denominator, which is what we see here. So we have our x into bracket x plus 2. And we are evaluating it at the value that makes B's denominator be 0. And that is 1. So evaluate it at x equals 1. Hence, we have what? For 1, we have 2 times 1 squared. That gives us a 2. So it is a 2 plus 3 times 1 gives us a 3, and then plus a 1 all over 1 times, this gives us a 3, and 1 times 3 simply gives us a 3. 2 plus 3 plus 1 gives us a 6, so we have a 6 over 3, which is equal to what? 2. Hence, our B is equal to 2. The last constant left for us to solve for is C. So using the same procedure, our c would be equal to a 2x squared plus 3x plus 1 all over. We are writing all the denominators excluding c's denominator. So x into bracket x minus 1. And then we are evaluating at x equals the value that makes c's denominator 0, and that is a negative 2. Hence, we have 2 times negative 2 squared. That gives us a 2 times 4, which is an 8. Then plus 2 times negative 2, that gives us a negative 6. Then plus 1 all over the negative 2 into bracket and negative 3. So we have an 8 minus 6, which will give us a 2. 2 plus 1 gives us a 3. So we have 3 over negative 2 times negative 3 gives us a 6. This one simplified gives us a 1 over 2. So we can then say our c is equal to 1 over 2. Hence, rewriting our fraction in terms of its partial fractions, we have 2x squared plus 3x plus 1 all over x into bracket x minus 1 and then x plus 2. And that is equal to our a. A was 1 over negative 1 over 2. So that is, by now we know how to easily write it. So we have negative 1 over 2x. Then our b, so plus, b was negative 2. So we have our 2 over x minus 1. And then plus our c, which is 1 over 2. So 1 over 2 into bracket x plus 2. As simple as that. So by now, I want to believe you can quickly check for your answer. With that, let's quickly look at the method of undetermined coefficient. So for the method of undetermined coefficient, we know we'd have to multiply each and every term by the LCD we have here. And for that, the left-hand side gives us a 2x squared plus 3x and then plus 1, which is equal to a. Now, if we are to multiply this whole LCM by this fraction we have here, the x just cancels out the x. And we'll be left with all of this. So that is to say we have a into bracket x minus 1, x plus 2. Then plus b, also into bracket. It just cancels out to the x minus 1. So we'll be left with what? We can simply write it as bx, then into bracket x plus 2. Bx because you are just going to multiply b by x and then by x plus 2. So why not just multiply your bx to give you your bx, then into bracket x plus 2. So that is what we've done over there. Then for the c, we have a plus c x as well, because the only thing that it cancels out is the x plus 2, and we left with what? The x times x minus 1. So cx into bracket x minus 1. So with that, we open the brackets. The left-hand side remains 2x squared plus 3x plus 1. Then opening these brackets, first of all, we have a into bracket x multiplies x, and then it multiplies 2 to give us x squared plus a 2x. Then negative 1 multiplies x, and then also multiplies 2 to give us negative x minus 2. That is it for the a. For the b, so we have plus b into bracket x squared, or since we can easily work that of b, we just say plus b x squared and then plus 2bx. how are we getting this? Bx multiplies x to give us bx squared. And then bx multiplies 2 to also give us what? 2bx. And then plus for the c, cx multiplies x to give us a cx squared. And then cx multiplies -1 to give us a negative cx. We now need to simplify further that of a. So for a, in the bracket there, we have x squared plus 2x minus x minus 2. So we can quickly rewrite it as x squared plus x minus 2. That is the 2x minus x. So all I'm going to do is we are going to clean all these we have here and then substitute it with what? X squared plus x minus 2. You see? So with that, it makes our evaluation simpler. So that on our left hand side, we maintain 2x squared plus 3x plus 1, which is equal to, so opening our bracket, we have a times x squared, which gives us an ax squared. Then a times x, we have plus ax, and then a times -2, giving us a negative 2a. Then for that of b, let's just arrange them nicely under their corresponding variables. So we have our bx squared, then plus 2bx. B has no constant. Then we go to the c. So plus cx squared, then minus cx. So if you want to group them, we are going to get, for the x squared, we have a plus b plus c, or x squared. Then for the x's, we have a plus 2b minus c, x. And for the constant term, we have a negative 2a. So we would now equate the exponents. Let's start with the constant term because that one will be very simple. So for the constants, we have 1 being equal to, that is, it's just 1 that is the constant here. So 1 is equal to negative 2a. So making a the subject, it simply implies a is equal to -1/2. And that is true. That is what we had for a, -1/2. Now, for the others, we have, so let's say for the x squared, we have 2, that is from here, 2, which is equal to a plus b plus c. That is what we have here. Easy. And with that, we can substitute our a quickly. So that we have 2 is equal to -1/2, then plus b plus c. If we bring -1/2 all the way to the left hand side, it is going to be 2 plus 1/2. And 2 plus 1/2 give us a 2.5, which is 5/2. And we say that is equal to b plus c. So this becomes our first equation. Then we come to for the x's. Let me just do that beside this. So for x, what are the coefficients of x? We have just 3 over here. So we say 3 is equal to, and then these are the coefficients of x in terms of the variables. So a plus 2b minus c. Substituting our a, we have 3 is equal to -1/2 plus 2b minus c. If you have to bring 1 over 2 to the other side, it becomes a 3 plus 1 over 2, which gives us a 7 over 2 is equal to 2b minus c. That becomes our second equation. We then need to solve. So solving simultaneously, then I'll use the elimination method. And in the elimination method, all I'm going to do is to add equation 1 to equation 2. They would say equation 1 plus equation 2. And that is 5 over 2, which is equal to b plus c, being added to the 7 over 2, which is equal to 2b minus c. With this addition, we know c plus a negative c goes off. You see, so the c has vanished and we'll be left with what? B plus 2b, which gives us a 3b. So we have 3b, which is equal to 5 over 2 plus 7 over 2. That gives us a 12 over 2, which is actually a 6. So 12 over 2, which is a 6. If we have 6 equals 3b, then making b the subject, it simply implies our b is equal to what? 2. And that is the same thing we had over here. B is equal to 2. You see? So with that, you now do your substitution to get the value of what? C. So to solve for C, all we are going to say is put your B into, let's put it into equation 1. And we know equation 1 is what? 5 over 2, which is equal to B plus C. And we have our B to be 2. So we have 5 over 2, which is equal to a 2 plus C. Making C the subject, we have 5 over 2 minus 2, which gives us what? Our C. So solving for C, it is simply 5 over 2 is 2.5. So 2.5 minus 2 would give us a half. You see, so we can say our C is equal to 1 over 2. And it confirms what we did over there. So you realize that both methods would give you the answer. And once again, I'm laying emphasis on the fact that it is best you understand both methods so that you can easily evaluate that of case 2 and then case 3 as well. So since we have our A, B, and C, we then substitute into this. That is, you are substituting it into this first one you wrote over here. And then you present your answer. That ends our lesson on case 1. As usual, I'll leave with some exercises so you try on your own just to test your understanding. So as you have seen, both methods work so well, and it should be to your own advantage to master them both. As usual, I'll leave with some exercises so you try on your own just to test your understanding. So here you have 5 questions based on all that we have done so far, and you can try your best to work them out. The answers should be provided in our next lesson, so you can check that out and then confirm what you have done. This is how Beyond Numbers, where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section, and when notified, I would attend to that for you. If this is your first time on this channel as well and think it will be of help to you, you can choose to subscribe if so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.